Hey everyone, and welcome to Top Scholars. We are going to discuss one shot in this session for real numbers. So I hope all of you are excited along with me. Let us begin straight away. As we know, real numbers, it comprises of rational and irrational numbers, right? So rational numbers, irrational numbers. In rational numbers, as we know, we have fractions. In integers, as we know, we have negative integers and whole numbers. And then further, in whole numbers, we have 0 and set of natural numbers, which are the counting numbers. So basically, real numbers, it comprises of rational numbers and irrational numbers, right? Okay. So we'll focus more on that. So let us talk about what is a factor. Factor, as we know, factor is a number that is multiplied by another number to get a product, right? So 2 into 4 is 8. So 2 and 4 are called as the factors of 8, isn't it? Right? So 2 and 4, both of them are what? They are factors of 8. And 8 is the product. This we are studying since childhood. So here 2 into 2 into 2. Again, these are all the factors and the product is 8. These are basically the prime factors, you can say, because 2 is a prime number. Now let us understand how to construct a factor tree. So write the number as a product of prime numbers and a composite number, and then you keep on factorizing till the end where you get product of all prime numbers. Say for example, here we have 144. So the first rule is, we'll begin with the smallest prime number. So we'll divide 144 by 2. So 144 can be expressed as 2 into 72. Rule number 2 says prime numbers are always on the left hand side of the factor tree. Okay, so prime numbers are on the left hand side of the factor tree. Then again 72, 2 into 36, right? 36 is 2 into 18, then 2 into 9. And then do not move to the next prime if it still divides by the same prime number, obviously. Now you get 9. Now till the time of 9 you see we have divided by 2. Now we will move to the next prime number, which is 3. So you can divide by 3. And then you get 3 into 3. That's it. And you stop here. That is 3 into 1 finally. But do not consider 1 because 1 is not a prime number, neither it is a composite number. So if you see, this is a factor tree. This is how you draw a factor tree, and you already know that, right? Okay. What are prime numbers? Prime numbers are those numbers having only two factors, 1 and the number itself. So 13 is an example of a prime number, 5 is an example of a prime number, 7 and so on. It has only two factors, 13 and 1. Correct? So indirectly we can say that a number which is divisible by 1 and itself is called as a prime number. Opposite of prime number is composite number. So what are composite numbers? Composite numbers are those numbers having more than two factors. Two factors are compulsory, 1 and itself. 1 itself. So whenever a number has more than two factors, it is a composite number. Say for example 16. 16 has 1 and itself as the factors, but 16 is divisible by 2. 16 is divisible by 4. 16 is divisible by 8. So 1, 2, 4, 8, 16, all of them are factors of 16. So definitely 16 is a composite number. Let us talk about the prime factors now. So prime factors are factors which are prime basically. So when you have a composite number, say 8, it is 2 into 4. 2 is prime, but is 4 prime? No, 4 is not prime. So we factorize it further, and if you see, 2 is a prime factor, 4 is a non-prime factor, 4 is a composite factor. That is why further we can express 8 as 2 into 2 into 2. Now here all the three numbers are prime, that is 2, right? And 2 into 2, again we have factorized 4, correct? Okay, so prime, 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 product of prime numbers. These are prime factors, simple. Okay, let's continue further. Now let us talk about the actual concept, the first concept, that is fundamental theorem of arithmetic. So every composite number can be expressed as the product of prime numbers in a unique way apart from the order of the prime factors. So the order of the prime factors does not matter, but every composite number, each and every composite number can be expressed as what? Product of prime numbers, right? This means each number has a unique prime factorization. Every number has a unique prime factorization. For example, express 140 as a product of its prime factors. So we have 140. We'll start by dividing with the lowest or the smallest prime number 2. We divide by 2. We get 70. Again divide by 2. You get 35. You divide by 2. We cannot divide by 2, right? Because 35 is an odd number now. So move to the next number. Is it divisible by 3, which is the next prime number? Again no, right? Not divisible. So divide by 5. The unit digit is 5. So you get 7. Then 7 itself is a prime number. Just divide by 7. And then you get 1. So yes, 140 can be expressed as 2 into 2 into 5 into 7. Okay, so yeah. So the prime factorization of 140 is 2 into 2 into 5 into 7. Simple, easy and straightforward, right? Nothing much in this. So this itself is a fundamental theorem of arithmetic, because if you see 140 is what? If you see very carefully, 140 is a composite number. But if you see 2, 2, 5 and 7, all of them are prime numbers, right? So all of them are prime. So every composite number can be expressed as product of prime numbers. Also 2 into 2. 2 appears 2 times, so we can write down 2 square into 5 into 7. Simple. Okay. Now let us see an example. Express 32,760 as a product of its prime factors. So 32760 divided by 2. You get 16380 divided by 2. 8190 divided by 2. 4095 divided by 3, because this is a odd number, you cannot divide by 2. Go with 3. It is divisible. 1365, go with 3. 455, go with 5. 91, 7, 13, 13, 1. Correct? So yes, we have expressed 32,760 as a product of its prime factors. 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13. Right? Okay. So here it is. So 2 into 2 into 2. How many times? 3 times. So 2 cube. 3 into 3. How many times? 2 times. So 3 square. 5 is ones. 7 is ones. 13 is ones. If you want, you can write 1 at the top. Okay. Now let us talk about the LCM and HCF. Now how do we find out the LCM and HCF? We are studying this since grade 6, so nothing new. HCF, it is also called as the highest common factor, right? So HCF is what? It is the product of the smallest power of each common prime factor in the given numbers. This is very interesting. Product of smallest power of each common prime factor in the given numbers. LCM is what? LCM is the product of the greatest power of each prime factor involved in the given numbers. So for any two positive integers a and b, always remember this is a very important relation, that HCF of two numbers multiplied by LCM of two numbers is always equal to the product of two numbers. HCF into LCM is product of two numbers, right? Okay, please make a note of this. Now the question says find the LCM and HCF of 6 and 20 using the prime factorization method. Now this is very simple, isn't it? Let's move on to the solution to this. 6. Can I write down 6 as 2 into 3? Yes. Can I write down 20 as 2 into 2 into 5, which is nothing but 2 square into 5 raised to 1. This is also 2 raised to 1. This is also 3 raised to 1. So whenever we take the HCF, see here, we'll take the common factor with lowest power. So can I say 2 raised to 1 is the common factor with lowest power? So that is 2. And whenever we take the LCM, We take the common factor with highest power. So can I say 2 raised to 2? But we also take the uncommon factors. Always remember this. So we'll take 5 raised to 1 also and 3 raised to 1 also. So into 5 raised to 1 into 3 raised to 1. 5 3s are 15. 15 4s are 60. HCF is 2, LCM is 60. Simple. And the new question says, find the LCM and HCF of 6, 72 and 120 using prime factorization. So firstly we have 6. Can we write down 6 as 2 into 3? Yes. Then we have 72. So if you keep dividing 72, you can do that separately. If you divide by 2, you get 36. You divide by 2, you get 18. You divide by 2, you get 9. You divide by 3. So that is 2 cube into 3 square. Right? And then you have 120. So for 120, if you divide this by 2, you get 60. You divide by 2, you get 30. You divide by 2, you get 15. You divide by 3, you get 5. You divide by 5, you get 1. So you get 2 cube into 3 into 5, right? The HCF is going to be, this is 2 raised to 1 and this is 3 raised to 1. So 2 raised to 1 into 3 raised to 1. So 6 itself is the HCF. What will be the LCM? Firstly, see the common highest power. In 2, 2, 2. 2 cube is highest. Write down 2 cube into. In 3, 3 raised to 1, 3 raised to 2, 3. 3 raised to 2 is highest. And then write down the remaining. That is 5. So 2 cube is 8 into 3 square is 9 into 5. Right? So 8 nines are 72. 72 into 5 is 360, right? So 360 is the LCM. Simple. Now let us move on to number theory, that if P is a prime number and if P divides A square, then P divides A, where A is a positive integer. Now this is very interesting. Now 3, does it divide 6 square? It divides 6 square. 6 square is 36. 3 divides 6 square. That is 36 is divisible by 3. So it will divide 6 also. That means it divides 6 also. That is 6 is divisible by 3. You can take the example of 2 and 100. Is 2 or does 2 divide 10 square? Does 2 divide 10 square? Yes. So does 2 divide 10? Yes. Right? Always remember, the sum or difference of a rational and an irrational number is always an irrational number. If you take the sum and difference of a rational and irrational number, it is always going to be an irrational number, right? So if we have 2 and root 3, 2 is a rational number, root 3 is an irrational number, then 2 plus root 3, not only that, 2 minus root 3. Not only that, root 3 minus 2 or root 3 plus 2, they are all going to be irrational numbers. Okay. Now we'll see root p is irrational where p is a prime number. Always remember, if p is a prime number, root p is going to be irrational. So 7 is a prime number, root 7 is going to be irrational. There are many examples. If 5 is a prime number, root 5 is going to be irrational. We are also going to prove those. So here we are supposed to prove that root 3 is irrational. So whenever we prove root 2 is irrational, root 3 is irrational, we are going to make use of the contradiction method. So firstly, we will assume the opposite of this. We will assume that root 3 is rational, right? How are we going to start? We are going to start by assumption that root 3 is rational. That is, we'll assume root 3 is now if we assume root 3 as rational, can I write down root 3 in the form of p by q or a by b, where a and b are co-primes, right? A and b are co-primes. Now what is the meaning of co-primes? Co-primes means there is no common factor between a and b apart from 1. Now if I transpose b to the other side, can I say a will be equal to root 3 times b? Now if I square both the sides, can I say a square is equal to 3 b square? Now a square is equal to 3 into something. A square is a product of two numbers. So can I say a square is divisible by 3 or 3 divides a square? Here I can say 3 divides a square. Now tell me one thing, if 3 divides a square, can I say 3 divides a? So 3 divides a. This is an important statement. I am marking this as statement number 1. If 3 divides a, then a is equal to 3 into something. So can I say a is equal to 3 into some number, say c. If I again square on both the sides, I will get a square is equal to 9c square. But understand, what is a square? A square is 3b square. So here, can I say 3b square is equal to 9c square? You can cancel out 9 and 3. So you get b square is equal to 3c square. So can I say 3 divides b square? Yes. So here I can say 3 divides b square. Now 3 divides b square. So can I say 3 divides b? I am marking this as statement number 2. Now observe, statement number 2 is 3 divides b and statement number 1 is 3 divides a. So can I say 3 divides a and b? So 3 is common factor. Three is common factor. Of what? Of a and b. But this is a contradiction. Why? This is contradiction to the fact that A and B are co-primes, right? A and B are co-primes. So we can say that our assumption is wrong. Our assumption is wrong. So what was our assumption? Our assumption was that root 3 is rational. This is wrong. And what is correct? Therefore, we can say that root 3 is irrational. See, if it is not rational, the other option is it is irrational. If I say a person is not a boy, obviously it is going to be a girl, right? The same way, if it is not rational, then it is going to be irrational, right? So I hope you have understood how to prove this. In the similar manner, we can prove root 2 as irrational. Now let us do it very shortly. Okay, root 2 is irrational. How do we start with? We start with assumption. What is the assumption? Let root 2 be rational. Let root 2 be rational. This is our assumption. So, what are we going to write down? We are going to write down root 2 is equal to A by B, where A and B are what? A and B are co-primes. Shift this. So, A will be equal to root 2B. So, what will be A square? A square will be equal to 2B square. So, 2 divides A square. That means 2 divides A, right? So, here we get 2 divides. Just see the steps. If 2 divides A can be written as 2 into C, again square. You get A square is equal to 4C square. But what is A square? A square is 2B square. So you get 2B square is equal to 4C square. You can cancel out 2. Once you cancel 2, you get B square is equal to 2C square. So 2 divides B square, 2 divides B. Two divides A and B. 2 is the common for both A and B. This is a contradiction. Contradiction to which fact? The fact that A and B are what? Co-primes. So our assumption is false, and then we can say that yes, root 2 is irrational. So these are the steps to prove root 2 irrational, root 3 irrational. They can ask you prove that root 7 is irrational, root 11 is irrational, doesn't matter. Let's continue. Now let us see the decimal expansion of rational numbers. So if x is equal to p by q is a rational number with the prime factorization 2 raised to n into 5 raised to m of the denominator, then understand where n and m are non-negative integers, the decimal expansion of x then comes to an end. That means it is terminating. So whenever the denominator is of the form 2 raised to n into 5 raised to m, it has a terminating decimal expansion. Always remember. And if you have any other factor apart from 2 and 5, then it has non-terminating but recurring decimal expansion. So, if a and b is a rational number, then its decimal expansion would terminate if both of the following conditions are satisfied. That is, HCF of a and b is 1 and b can be expressed as the prime factors of 2 and 5. HCF of a and b is 1 and both can be, b can be expressed, that is the denominator can be expressed as the prime factorization of 2 and 5. So denominator as in this part, and here they are talking about a by b. So basically the HCF of the numerator and the denominator has to be 1, and the denominator should be of the form 2 raised to n into 5 raised to m. It can also include only 2 as the factor, it can also include only 5 as the factor, doesn't really matter. But 2, 5, there should not be anything apart from 2 and 5. Okay. That is in this form. Correct? So here it is. Now let us try to understand an example. Determine if there is any natural number n for which 4 raised to n ends with digit 0. So the question says, does 4 raised to n ends with digit 0? Now see, for a number to end with 0, can I say it requires two factors 2 and 5? For example 10. See, 10 is what? 2 into 5. If I have 20, 2 into 2 into 5, that is 2 square into 5. Even if I take 30, suppose, that is 2 into 5 into 3. 2 and 5 definitely is there, 3 is extra. So for any number to end with 0, we need the two factors to be 2 and 5. Now we have what is given. Given is 4 raised to n. Can I write down 4 raised to n as 2 into 2 the whole raised to n? So here can I say 2 raised to n is a factor of 4 raised to n, but what is missing? See, 2 is there, 5 is not there, but 5 is not a factor. Therefore, we can say that 4 raised to n cannot end with 0. So 4 raised to n can never end with 0 because the missing factor is 5, right? Okay, let's continue. Now let us talk about Euclid's division lemma. So Euclid's division lemma, it also serves as a base for Euclid's division algorithm, which is used to find out the GCD or the HCF of any two numbers. It also gives the relation between various components of division. We know that dividend is equal to divisor into quotient plus remainder. So Euclid's division lemma says that A is equal to BQ plus R, where A is a dividend, B is the divisor, Q is the quotient, R is the remainder, and remainder is always greater than equal to 0 less than B. Although this part is not there in your syllabus, but there are some applications which might be helpful for you. So 19, if you divide 19 by 6, you get the quotient as 3 and you get the remainder as 1, right? So you can see 1, the remainder 1 is greater than 0 but less than 6, right? So A is equal to BQ plus R, dividend, divisor, quotient, remainder. Simple? Okay. Now comes an interesting question. The LCM of two prime numbers P and Q is 221. Then the value of 3P minus Q is what? The LCM of two prime numbers. Interesting. The two numbers are prime numbers. So let's move on to the solution. So if I suppose the two numbers to be say P1 and P2 or P and Q, it is already given P and Q, are the two numbers. What is their HCF? Can I say their HCF . of P and Q is going to be 1. And also, if I prime factorize 221, can I say 221 after prime factorization, if I divide this by 13, I get 17, and if I divide this by 17 further, I get 1. So basically my two numbers are 13 and 17, right? But understand, here P is greater than Q. P is greater than Q. So can I say P is going to be my 17 and Q is going to be my 13. So two numbers are 17 and 13. Their HCF is 1. Now 3P minus Q. This is simple. So 3P minus Q is going to be 3 into 17 minus 13. So that is equal to 51 minus 13, which is equal to 38. Right? So 38 is the final answer and C is the correct option. Clear? Okay, let's continue. If n is any natural number, then 12 raised to n cannot end with which of the following digits? This is very simple. See, 12 raised to n. Now 12 raised to 1, 12 raised to 2, 12 raised to 3 and so on. It cannot end with what? So if I see the factors of 12, can I write down 12 raised to n as 2 into 2 into 3 raised to n? So can I say it includes the factor 2? It includes the factor 2. It includes the factor 3. Now if I talk about 2, 2 already has a factor 2. If I talk about 4, 4 is 2 into 2. 8 is also 2 into 2 into 2. So first three numbers, all of them contain the factor 2, which is already there in 12 raised to n. But can it end with 0? No, because we know that for a number to end with 0, it should need 2 as well as 5. So can I say the factor 5 is missing? Missing for this number to end with 0. So it cannot end with 0 because 5 is missing in this case. Correct? Let's continue further. So let us have a look at a new example. It says the LCM of x and 18 is 36 and the HCF of x and 18 is 2. Then what is the value of x? The two numbers, if I say the two numbers a and b, so a is x, b is 18, LCM is 36, HCF is 2. We know that LCM into HCF or HCF into LCM doesn't matter. HCF into LCM is A into B. So HCF is 2 into LCM is 36 is equal to A into B. A is x into B is 18. So you can divide 18 and you get x is equal to 2 into 36 divided by 18. So 18 ones are 18 twos are 36. 2 into 2 is 4. So can I say x is equal to 4 is your final answer? Simple. Let's continue. Oh, we had options here. Great. So we had options here. No problem. 4 is the right answer. Let's have a look at a new example. It says, what is the HCF of the smallest prime and the smallest composite number? Interesting question. Smallest prime and smallest composite. So what is the smallest prime? What is the smallest prime number? Can I say the smallest prime number is 2? What is the smallest composite number? The smallest composite number is 4. We are supposed to find out the HCF. Two raised to 1. 4 can be written as 2 raised to 2. So what is the smallest power to take the HCF? So basically the HCF of smallest prime number, which is 2, and the smallest composite number, which is 4, is 2 raised to 1, which is 2. It's a very simple and a straightforward question. They can also ask you the LCM. The LCM will be 4, right? They can also ask you the product of the HCF and LCM. Just take the product. 4 to the 8. Now let's have a look at a new question. So the statement says, this is an assertion and reasoning question. If the product of two numbers is 5870 and their HCF is 17, then their LCM is 340. So statement 1 is, HCF is always a factor of LCM. That is the reason. A says both assertion, so this is the assertion and this is the reason. Both assertion and reason are true, and reason R is the correct explanation of assertion A. B option says both assertion A and reason R are true, and reason R is not the correct explanation of assertion A. Assertion A is true but R is false, and A is false but reason is true. Firstly, let us find out whether A is true or not. We have 5780 as the product of two numbers, HCF is 17, LCM is 340. So if you see the product of two numbers, that is A into B, suppose, the product of two numbers is 5780 right? HCF is 17. LCM we don't know. They have given, but we need to check whether the assertion is correct or not. So can I say A into B, product of two numbers, is equal to HCF into LCM. So A into B, 5780 is equal to HCF, which is 17, into LCM. To get the LCM, we'll divide 5780 by 17. So 17 threes are 51, 6, 8, 17 fours are 68. You get a 0 and then you have a 0 here. So 340. Okay. So the LCM is 340. Let's go back. So HCF is always a factor of LCM. That is fine. But both assertion and reason are true, and reason R is the correct explanation of A. That was the first option. Second is both assertion and reason are true, and reason R is not the correct explanation of. So tell me one thing, is this reason HCF is always factor of LCM, is this enough to say that the LCM is 340? Did we use this? What did we use? We used the concept of product of two numbers is equal to the HCF into LCM. So this is incomplete. Even if we know this, which is true, it is not the explanation for A, right? So firstly, assertion is true, reason is false is wrong, because reason is correct. Assertion is false, that is also wrong, because assertion is correct. And here if you see, HCF is the factor of LCM, yes, but this statement is not the explanation to the previous one. This is true, but the explanation is not for A, right? That is the correct answer. So B is the correct option. Okay, let's continue. So let us have a look at a new question. It says, find the least number which when divided by 12, 16 and 24 leaves a remainder of 7 in each case. So we have 12, 16 and 24. All we need to do is, you find out the LCM, then add 7. That's it. That is your final answer. So for that, let's begin with the number 12. Can I write down 12 as 2 square into 3 raised to 1? Can I write down 16 as 2 raised to 4? And can I write down 24 as 2 cube into 3? The LCM is equal to, from this, we'll take the highest power, that is 2 raised to 4 into, from here, we'll take 3 raised to 1. So 2 raised to 4 is 16 into 3 is 48. Now understand. Find the least number when divided by 12, 16 and 24. So is 48 divisible by 12? Yes. Is 48 divisible by 16? Yes. Is 48 divisible by 24? Yes. So whenever you will divide 48 by 12 or 16 or 24, the remainder is going to be 0. Now you want, see, even if this is 24 or even if this is 16, the remainder is going, forget about the quotient, the remainder is going to be 0. Now we want the remainder as 7 in each case. So what you do is, just add 7 to 48. So the number that you get is 55. So 55 is the least number which when divided by 12, 16 and 48 leaves a remainder of 7, and that is your final answer. I hope you understood this question. Very tricky but simple. That's it. Now the new question says, two numbers are in the ratio 2:3 and their LCM is 180. What is the HCF of these numbers? Now two numbers are in the ratio. So the ratio of two numbers is given. So if I take the common multiple as x, can I say the two numbers are, if the common multiple is x, two numbers are 2x and 3x, right? So this is like your A and B. This is like your A, this is your B. Their LCM is given. LCM is 180. What is their HCF? We know that LCM into HCF is the product of two numbers. So HCF into LCM is equal to A into B. Right? So can we say here 2x into 3x is equal to HCF, which we don't know, into LCM. LCM is 180. Now understand, it comes very tricky here. LCM is there, here also we have an unknown, HCF is also unknown. So can I say from 2x and 3x, this is the common multiple. So can I say the HCF is x? So can I say the HCF itself is going to be x, which is the common multiple? So I get x into 180 is equal to 2 into 3 is 6. 6 into x square. X and 1x gets cancelled. So can I say x will be 180 divided by 6? Which is equal to 30. Now say x is 30. So once we get x as 30, that itself is the HCF. So can I say the HCF is 30. That's it. So the HCF is 30. So let's have a look at a new question. It says define an irrational number and prove that 3 plus 2 root 5 is an irrational number. So basically what is an irrational number? A number that is not rational is an irrational number. One of the ways of defining it is irrational number is a number which cannot be expressed in the form of P by Q. That is, the decimal expansion is non-terminating, non-recurring. That is another definition of an irrational number. Now we are supposed to prove that 3 plus 2 root 5 is an irrational number. There are two ways of proving it. We'll prove it in two ways. So 3 plus 2 root 5. Now we know that product of rational and irrational number is irrational. But here, can I say 3 is a rational number? Can I say 2 is a rational number? Root 5 is an irrational number. What is product of rational and irrational? Product of rational and irrational is irrational. This part, entire 2 root 5. So 2 root 5 is irrational. Now what is sum of rational and irrational numbers? Sum of rational and irrational is irrational. So can I say 3 plus 2 root 5 becomes irrational now? So finally we can conclude that therefore 3 plus 2 root 5 is irrational. So this is one of the ways of doing it. Other ways, the definition was asked. This is the definition, right? That it is not a rational number. It cannot be expressed in the form of p by q, where p and q are integers. The other way is, you assume, let 3 plus 2 root 5, assume 3 plus 2 root 5 is a by b. That is, assume it is rational. We are assuming that 3 plus 2 root 5 is a by b. So from here, 2 root 5 will be equal to a by b minus 3. You can divide by 2. So root 5 is equal to a minus 3b by 2b. What is root 5? Root 5 is irrational. What is this? This is rational. So we can say that, but root 5 is irrational. So this contradicts that irrational number is equal to rational number. Therefore, we can say that 3 plus 2 root 5 is an irrational number. So there are two ways of solving this. Either of the ways is fine. Let us have a look at one last example. The LCM of two numbers is 182 and their HCF is 13. If one of the numbers is 26, find the other. So the LCM is given, HCF is given, one number is given, find the other. So this is a very simple question, isn't it? The LCM is how much? LCM is 182. HCF is how much? HCF is 13. One of the numbers, so let A be equal to 26. Let the other number B be what we are supposed to find out. HCF of A and B into LCM of A and B is equal to A into B. So we know that A into B is equal to HCF into LCM. So A is 26 into B is equal to HCF, that is 13 into LCM is 182. So B is equal to 13 into 182 divided by 26. You get 13 ones are, 13 twos are, 2 ones are, and 2 91s are. So the final answer is 91. That means the the other number is 91. Let's have a look at one last simple example. It says an army contingent of 678 soldiers is to march behind an army band of 36 members in a Republic Day parade. The two groups are to march in the same number of columns. The two groups are to march in the same number of columns. What is the maximum number of columns they can march in? Always remember, the key to the question is hidden in maximum minimum. So maximum means highest. So here we are supposed to just find out the HCF. All you need to do is find out the HCF of 678 and 36. What you will do is find out the HCF of 678 and 36 to find out the maximum number of columns in which they can march provided in the group they have same number of columns. So if you find out the HCF from here, the HCF of 678 and 36 is nothing but 6. And that's it. That is your answer because the HCF is 6. So you can say that the maximum number of columns in which they can march is 6. And I'm very sure you know how to find out the HCF. Prime factorize this, and then finally you get the HCF by taking the common factors with the lowest power. Simple, isn't it? So that's it on real numbers. I hope you enjoyed the session. Next time we are going to talk about polynomials as well. See you next time. Until then, keep learning with top scholars. Thank you.